Hello everyone. So today we'll be looking at the GMAT quantitative reasoning section. So what do we have in the QR section? So the topics I'll just quickly give you a brief idea of. So we have the arithmetic section, which includes all of that starting from percentages, then ratios, rates, work and distance, that is, averages, basic concepts of statistics also comes in. So all of this together is the arithmetic section. After that, we have the algebra section where we look at equations, primarily linear and quadratic equations, some basic concepts of functions, okay, some basic ideas of series and sequences, and coordinate geometry. Then moving on, we have plane geometry where we have all plane figures like lines, then triangles, polygons, circles. Plus, we also have solids, 3D shapes. So 3D shapes primarily would include cylinders and cubes or rectangular solids. After that, the most important part, number properties, which is often clubbed as a part of arithmetic, but just because it's so vast, I treat it as a separate topic altogether. So number properties include all types of numbers, okay, all real numbers only. So types of numbers, then divisibility rules, okay, then factorizing factors of a number, the GCD and the LCM concepts, okay, then multiples of a number, like not only the least common multiple, but multiples in general of numbers, factorials, units digit, remainders, and other miscellaneous properties. That also is a part of the course. Along with that, we have inequalities, which is when clubbed with number properties becomes a very potent combination. So inequalities is a part of algebra, though I club it under number properties because most questions of inequalities would be keeping in mind number properties along with it. Okay, so inequalities would include linear, quadratic, also the concept of the number line, okay, the inequality line, the number line, and modulus, absolute values, okay, all of these would be a part of number properties, inequalities. Finally, we have the last section, which is combinatorics, which includes topics like permutation and combination, probability, and sets. So sets would include like questions on Venn diagrams mainly. Okay. So this is roughly the entire course. So today what we will be doing is a brief introduction to the concept of averages. Okay. Just to give you some idea of what it is like. So we'll look at the idea behind averages. It's a very common topic. Most of you would be knowing what an average is, but still, why we are doing this? Just to showcase different approaches that we use here, which are different from the methods that we have been using throughout our lives. Okay, so like averages, everyone just understands is the sum of the terms that you have divided by the number of terms, isn't it? So for example, let me just write that down. So average is sum of the terms, whatever the terms are, divided by the number of terms that you have. Okay, but this alone doesn't really help a lot. Okay, let me just work on this a little bit. Okay, just to give you an idea, say the sum of the terms are x1, x2, x3, just three terms, and the average is m. Let's call it the mean. So x1 plus x2 plus x3 divided by 3. Now cross multiply. Then this is pretty obvious. Okay, I'm doing a bit of algebra just to show you a different result that is very important. Now take the 3m's to the left hand side. Okay, So we get x1 plus x2 plus x3 minus 3m is equal to 0. So everything I've taken to the one side. Okay. So this is equal to 0. Now rewriting it as x1 minus m plus x2 minus m plus x3 minus m is 0. Now this is a very useful result, okay, which we actually never use in our calculation or questions on averages. We just focus on this property, sum of the terms by number of terms, and solve from there. But you'll see how this one makes life so much easier. So what is this saying? If you have a mean and if you subtract the mean from each of the terms, the sum of those terms that you get by subtraction will be 0. This difference, or after subtraction what you get, let's call it the deviations. Okay, deviation for the first one, deviation for the second one, and deviation for the third one. Please mind, I'm not talking of standard deviation. Okay, don't confuse it with that. It's just deviation. Okay, just the gap with the sign. Okay, so not difference in that sense, because difference just means the absolute difference, absolute gap. So here I'm saying deviation. So the mean, the number minus the mean is subtracted from the number. The sum of that will be 0. So a very important property which says sum of deviations about the mean. The deviations about what? Deviations about the mean. So sum of the deviations about the mean is 0. Now, how do we use this? So we have learned all this. That's all nice. Okay, but how do we use this property? Okay, so let us see in a question. So I give you a question which says the numbers 83, 89, 97, 94, and x have a mean which is say 91. You have to tell me what this value of x is. So normally, how would we do it? We would say that, all right, so sum is the mean is 91. Excellent. So we have 83 plus 89 plus 97 plus 94 plus x upon 5 is 91, and we'll solve, right? Let's solve it. So let's easy add 83 and 97. So 7 and 3 make up a 10. So that's 90 and 90. That's 180. 180 plus 90 is 270. One less. We'll keep that aside. Okay. 270 plus 90 is 360. Now 360 plus 4, 364 minus that 1. So 363. Okay. Plus x is 5 times of 91. So x comes out to 92. So the method wasn't very difficult, but we had that big calculation to do. We multiplied that 5, then subtracted all those terms from that result. That gave us the value of x. Now, can we do something faster? Because I mean, this takes time, right? And since calculators are not allowed, unfortunately, what if you make a mistake in the addition? Then you end up getting it wrong. And unfortunately, if that option is there in the answer choice, so then you would have no way of understanding that you're done it right or wrong. Okay, so how do we avoid this calculation? So what did I say here in the previous page? That sum of the deviations will be 0. So let's use that. Find out the deviations. So we have 83, 89, 97, 94, x giving you 91 as your mean. Subtract 83 minus 91. So that is 8. Then this is 2 minus 2. Then this is 6. And that's 3. These, if you look, add up to how much? 6 plus 3 is 9. Minus 8 is 1. 1 minus 2 is minus 1. So in order that all of them add up to 0, this x must contribute a plus 1. So that minus 1 plus 1, sum of the deviations will be 0. The fact that it contributes a plus 1 means what? That x must have been 1 more than 91. So the value of x is 92. It's a much simpler calculation. It's much more neat, and chances of making a mistake by adding big numbers also is less. Also, it's faster. So obviously, lot of advantages if you follow this method. Now, not only this, let's quickly go to the concept of weighted average. So what is a weighted average? So weighted average is where you have a frequency. For example, I tell you that in a class, there are say 24 students, So there was a test, for example, let's say, okay. So there were 24 students who scored, let us say 36, or let's say 30 marks each. Let's just keep 36. I just want you to look at a bad calculation. So you have 24 students scoring 34 each, and there were another 16 students. Okay, another 16 students who, let's say, scored 27 marks each, or let's take 28 marks each. Okay, I want to figure out what is the average score for the entire class. Okay, so you'll have to figure out normal process. The normal process for this question would have been 24 students, 36 each, plus 16 students, 28 each, whole thing, total marks. This is total marks divided by total students, 24 plus 16. Now, as you can see clearly, it's a bad calculation, right? And I don't want you to do this calculation either. Now, is there a way by which we can avoid this entire calculation thing? So there are two ways in which we can do it. First, when I'm saying 24 students and 16 students, think it in this way, that what's the common factor for 24 and 16? That's 8, right? This is 8 threes are, this is 8 twos are. So if I take groups of 8 students, so in the first class, which had 24 students, so there were 8 students, another 8 students, another 8 students, right? And each group scored 36 each. Right? 24 students, 8 students, 8 students, 8 students. So 8 plus 8 plus 8, isn't it? And in the second group, when it's 16, I can say 8 students who scored 28 marks, another 8 students who scored 28 marks. I want to find out the average of these. I want to find out the average of these. Now look, everywhere it is 8 students, isn't it? Here also and here also. So instead of these 8 students who scored 36 and 8 students who scored 36, can't I replace them by a common factor saying that there was only one student? So what I'm trying to do here is, see, from top, if I take out 8 common, it's 3 times 36 plus 2 times 28 divided by 8 common, 3 plus 2. It's as if instead of 24 and 16 students, there were 3 students and 2 students. So basic idea is cancel out the common factors. So cancelling out 8, we have 3 and 2. So that's what I was showing here, that there are effectively 3 things here and 2 things here, whose average is 36 for the first class and 28 for the second. What is the average then for the whole thing? So it is simply 36 times 2, 3, plus 28 times 2 upon 3 plus 2. Which is a much easier computation than the previous one. How much is that? This is 108 plus 56. So 108 plus 56 is how much? 164. 164 by 5 is how much? 32.8 marks is the average for the entire class. Correct? So this is done. Now can we do something even better? Okay. So that will be my last trick which I show for today. So we have already reduced it down to 3 students and 2 students. You would argue that this is enough. Okay, I don't need much anything shorter than this, but we can do something a little even shorter. So here we had an average of 36 marks and here we had an average of 28 marks. What I propose is, what does an average say? For example, if I tell you what is the average of 1, 2 and 3, so you will say 2. If I add the same constant to each of them, say 10 I will add, 11, 12 and 13. What is the mean? 12. So that means if each number gets increased by 10, the average will also get increased by 10. If each number gets reduced by 10, the average will be reduced by 10. If I, let's say, reduce by 2, then it will be 9, 10 and 11. The average is 10, which is also reduced by 2. So we are going to use that property now and say that let me reduce everything by 28. So this group scored 0 marks and this group just scored 8 marks. What is the mean? 3 times 8 plus 2 times 0 divided by 3 plus 2. So 24 over 5. So that's 4.8 marks. But observe, I have reduced everything by 28. So the actual average would be, you must add back that 28. So 28 plus 4, 32.8 marks. So this is your answer for the average. So see how many ways we reduce the calculation. Okay, this was the main question. This was the actual computation. We reduce it straight away to 3 and 2 by taking ratio of the weights. These are the weights or the frequency. And for the marks, I just reduced the value by 28, made them smaller, computed the result, and just remember to add back that what you reduced. So we discussed two concepts here. One was how to compute the average quickly. The second concept is if the average is given and something else, missing term is there, then we can very easily use the sum of deviation zero property to solve for that. I hope this was clear and I hope you liked the class. Thanks for joining in. Bye everyone.